Hey students, welcome back. Now I am starting with the next episode where we are going to talk about some very cute, simple derivations. Very simple derivations. And those formulas are going to help us in understanding multiple choice questions also and problems also. Check the title please. Boyle's law on the basis of kinetic theory of gases and P equal to 1/2 square. What we derive, right? That means we are going to derive Boyle's law but taking help of P equal to 1/2 square. Now what was the statement of Boyle's law, students? What was the statement of Boyle's law? The statement of Boyle's law was pressure of gas given mass of a gas is inversely proportional to volume keeping temperature constant. Pressure of given mass of a gas is inversely proportional to volume provided temperature is constant. So if I solve this, will this be P is equal to some constant of proportionality upon V, and therefore we have to prove that PV is equal to constant. We have to prove that PV is equal to constant, but mind you, we should take help of P equal to 1/2 square. So very simple and cute proof, right? P is equal to 1/2 square. Yes. Therefore, P is equal to 1/3 rho का मतलब mass of the gas upon volume of the gas times c square. So it is m dash upon v c square. PV मुझे कांस्टेंट प्रूव करना है. PV तो ये वॉल्यूम मैं शिफ्ट कर लेता हूँ. So I will get PV is equal to 1/3 m dash पर मैं लिखूंगा mass of one molecule into number of molecules times c square. Yes or no? Now check what I am writing. PV is equal to 1/3 को मैं 2/3 into 1/2 लिखता हूँ. 1/3 को मैं 2/3 into 1/2 लिखता हूँ. Multiply and divide by 2. mn c bar square. And now check please. Now check. Half mc square is kinetic energy of one molecule. Right? Kinetic energy of one molecule into number of molecules is kinetic energy of all the molecules. So can I write PV is equal to 2/3 n times kinetic energy of a gas molecule. Kinetic energy of a gas molecule, don't you think, is constant at constant temperature. Temperature constant है ना बेटा? We say the postulate that but kinetic energy depends on temperature, and since temperature is constant, therefore kinetic energy also should be constant, and therefore PV is equal to 2/3 n. 2/3 is the number, so constant. चेतन मैं लेक्चर रिकॉर्ड करो 10 मिनट आप प्लीज. आप 10 मिनट आप ना लेक्चर रिकॉर्ड करो प्लीज. हाँ बोलो स्टूडेंट्स ले क्या है अभी करो करा please. Thank you sir. Sorry students, it was very urgent. I am so extremely sorry. So PV is equal to 2/3 into n into kinetic energy of gas molecule is constant number. So constant into constant is a constant, and then we prove Boyle's law. PV is constant. Target accomplished. Proof. Okay. So let's say there were 2-3 very simple proofs. This was the first one. Boyle's law on the basis of kinetic theory of gas. Okay. Now before I do other proofs, let me just take a picture of this. Just excuse me students. There we are. Okay. So now we are going to do another 2-3 simple proofs, of which one is what is the expression for RMS velocity of gas molecules. what is the expression for RMS velocity of gas molecule? I'm sure you have understood. Boils on the basis of kinetic theory of gases. So I will now go for all the proofs together. Okay. So please remember KTG lecture 1C is completely dedicated to P equal to 1/3 rho c square, and lecture 1B is dedicated to three small proofs. One is Boyle's law on the basis of kinetic theory of gases. Next is expression for RMS velocity, and then finally it is going to be expression for kinetic energy per kilomole, per kilogram, per molecule, and per volume together. That means there are four formulae, but that will be done under one article only. So, two another very simple proofs coming up. The first one, Boyle's law is done. So, second one, expression for RMS velocity of gas molecule with the help of P equal to 1/3 rho c square, or as we can say on the basis of P equal to 1/3 rho c square. That means our start should always be P equal to 1/3 rho c square. Is it not very important derivation therefore? Don't you think P equal to 1/3 rho c square? Therefore, it's very important. Here we are. Again, very simple proof. As I say, my start is, we have P is equal to 1/3 rho c square. Stop. P is equal to 1/3 rho is m by v, m dash by v, c square. Please note, I want to find out expression for RMS velocity of gas molecule. What is the meaning of RMS? C bar square root, है ना? Root mean square velocity. That is the meaning of RMS. That is, my focus should be on this. So can I say C bar square therefore is equal to 3 into PV upon m dash. 3 PV upon m dash. Let us keep this aside for a while, because now we have to take judgment of two things. One, for 1 kilomole of a gas, and which is m dash upon m is 1. Therefore, m dash first of all can be replaced by m. Point number 1. M dash can be replaced by m. Then the denominator I am going to write it as molecular weight. Also, for 1 kilomole of a gas, also PV is equal to nRT. N की जगह पे 1 becomes PV is equal to 1 RT. That means PV is equal to RT. तो इसको मैं हैश बोल देता हूं, जो मैं इधर रखूंगा, और इसको मैंने स्टार बोल के रखा हुआ है, वो मैं इधर रखूंगा, ये स्टार इधर रखूंगा. ओके, तो कैन आई से substituting star and hash in equation 1, I get C bar square is 3RT upon M, and then I get very simple relation. C bar square का root is root of 3RT upon M. Right? This is nothing but CRMS. And this is our main hero of the story. Now here there are three possibilities. One, C bar square का root is directly proportional to root of temperature. Right? इसको C बार स्क्वायर का रूट लंबा चौड़ा नहीं लिखता हूं, CRMS लिखता हूं. CRMS का दूसरा रिलेशन, it is inversely proportional to root of molecular weight. और तीसरा और आखिरी रिलेशन, CRMS is directly proportional to root of temperature and inversely proportional to root of molecular weight. थोड़ा कॉमन सेंस अप्लाई करो बेटा, बहुत इजी है, बहुत इजी है। RMS velocity is directly proportional to root of temperature provided molecular weight is constant, right? When you want to establish relation between two, तीसरा constant रखो। C is inversely proportional to root of molecular weight provided temperature is constant, right? And C is dependent on both if both are not constant. M and T both are not constant. If none are constant, if none are constant। अब थोड़ा लॉजिक अप्लाई करो बेटा, टेम्परेचर बढ़ेगा, gas molecule will move more vigorously. So as the temperature increases, RMS velocity increases, but with the relation to root of temperature, as you can see। Next, temperature से रखो, लेकिन gas change करो, gas, right? Don't you think lighter gas will move faster? Lighter gas will move faster. Hydrogen, helium, nitrogen, oxygen. Hydrogen molecular weight 2. Helium molecular weight 4, nitrogen molecular weight 28, oxygen molecular weight 32. Which gas molecules will move faster? Hydrogen. And among these four, which will move the slowest? Oxygen. Heavy people go slow, lighter people go fast. They can run fast. Are you getting my point? इसका मतलब अगर इसको मुझे और थोड़ा डिटेल में लिखना है तो मैं ऐसे लिख सकता हूँ। पहला रिलेशन T1 upon T2 is root of T1 upon T2। दूसरा रिलेशन C1 upon C2 is root of M2 upon M1, उल्टा। एंड तीसरा रिलेशन C1 upon C2 is not only root of T1 upon T2 but also root of M2 upon M1। So these are very useful formulae for solving problems and for solving multiple choice questions। Very useful formula। ओके, ये अपना एक डेरिवेशन हो गया। अब इसका जो दूसरा डेरिवेशन है ना, बैक टू बैक सिमिलर है। स्टूडेंट ट्रस्ट मी, वेरी इजी। और मैं जो स्टाइल में बोर्ड कर रहा हूं, आप यही स्टाइल में ये प्रूफ लिखोगे, बिकॉज इट इज वेरी वेरी इजी स्टाइल, राइट? My next and the last article of this particular episode is derivation 2, derivation 3. Expression. In fact, I would like to make it plural. Expression for 1 by 1 kinetic energy per kilomole. Next, kinetic energy per kilogram. Next, kinetic energy per single molecule. And last, kinetic energy per volume। Trust me students, ये मेन है, ये kinetic energy per kilomole। एक बार वो आ गया ना, बाद में सब सिंपल है। The proof begins from P equal to 1/3 of C square। Derive, ये ऑलरेडी प्रूफ बोर्ड पे ऐसे मैं उसके पीछे टाइम वेस्ट नहीं कर रहा हूँ। C bar square is 3RT upon M. That is it. ये derive करो from P equal to 1/3 of C square। ये derive करो and then see what needs to be done। C bar square is 3RT upon M, multiply both sides by half M। Yes or no? Correct? ये आपका M गया, half MC square is kinetic energy for 1 kilomole of a gas, because if it is 1 kilomole of a gas, M dash can be written as M। तो लेफ्ट हैंड साइड को मैं सीधा लिख सकता हूँ, kinetic energy per kilomole। It is not very cute and easy। Kinetic energy for 1 kilomole of a gas is given by 3/2 times R times T। Out of 4 formulae, first one is come, right? First one is come। Other three are very simple. Try to understand why। 1 kilomole का मतलब होता है n किलोग्राम। 1 kilomole का मतलब होता है m kilograms। That means this is the formula. If it is for 1 kilomole, is it also for m kilograms? Yes or no? So can I say kinetic energy for 1 kilogram is 3 by 2 RT upon m. अगर ये आंसर n किलोग्राम का है, if this is the answer for n kilograms, then what is the answer for 1 kilogram? Divide by m, obviously. Divide by m, right? तो करना कुछ नहीं था बेटा, ऊपर का जो फॉर्मूला आया ना, ऊपर का फॉर्मूला, उसको खाली मॉलिक्यूलर वेट से डिवाइड करो, राइट? और इसको आप एक और स्टाइल में लिख सकते हो, देखो प्लीज। इसको आप और एक स्टाइल में लिख सकते हो, देखो प्लीज। R by m, R by m can be write this as छोटा है ना, 3 by 2 छोटा r times t, because sometimes they will give you universal gas constant for 1 kilogram in place of 1 kilomole. Next one or be easier. 1 kilomole, you know that it is Avogadro's number, N0 molecules, है ना? 1 kilomole is N0 molecules. Common sense apply करो. If this is the answer for 1 kilomole, that means this is the answer for N0 molecules, all the molecules, right? What is N0 beta? What is N0? 6.03 into 10 is to 26 molecules. मतलब ये आंसर कितने molecules का है? 6.03 into 10 is to 26 molecules. So what is the kinetic energy for one molecule? What is the kinetic energy for one molecule? Common sense apply करो. 3 by 2 RT upon Avogadro's number. Upon Avogadro's number. और एक चीज देखो बेटा, और एक चीज देखो, R by N0 is Boltzmann's constant. Boltzmann's constant. So this can also be written as 3 by 2 kT. This can also be written as 3 by 2 kT. So kinetic energy per molecule is also 3 by 2 kT. है ना? ये देखो, काइनेटिक एनर्जी पर किलोमोल हो गया, काइनेटिक एनर्जी पर किलोग्राम हो गया, काइनेटिक एनर्जी पर मॉलिक्यूल हो गया। तीनों फॉर्मूला ध्यान से देखो बेटा। इधर 3 by 2 RT था, खाली डिवाइड बाय बड़े आंसर कर दो। इधर 3 by 2 RT था, खाली डिवाइड बाय 0 कर दो। लास्ट वन तो एकदम इजी है। लास्ट वन तो एकदम इजी, एकदम इजी। काइनेटिक एनर्जी पर किलोमोल इज 3 by 2 RT। इसको मैं 3 by 2 PV भी तो लिख सकता हूं ना, बिकॉज PV is equal to RT, है ना? PV is equal to RT। बस बेटा ये वॉल्यूम शिफ्ट कर लो, ये वॉल्यूम शिफ्ट कर लो और नीचे लेके आओ। सो व्हाट इज काइनेटिक एनर्जी पर वॉल्यूम? इज इट 3 by 2 into pressure? Is it 3 by 2 into pressure? इतना देखो, पहले RMS वेलोसिटी, और अगर ये पार्ट में आपको ये डिराइव नहीं करना था, डायरेक्ट बोल सकते हो कि from P equal to 1 by 2 c square, you know that c bar square is 3 RT upon m. Yes or no? So there, the first lecture gets over, and all the mathematical small concepts are also getting over. We are going to make use of all this in solving the problems in the next class, in understanding some points of synopsis, and in understanding the list of formulas, right? So before my next lecture, please revise extremely well. God bless you. Thank you very much.